Let's learn in this Lightboard session about IMDS Instance Metadata Service and how it could present a security issue when using AKS with managed identity. So in an AKS cluster, we have the control plane, but we have also the worker nodes that are presented as a node pool in our cluster. And that node pool behind the scenes is actually a virtual machine scale set. It's VMSS in Azure. And that node pool is a group of virtual machines. So we would have here one or multiple virtual machines. We can have also one or multiple node pools within an AKS cluster, and those VMs actually will share the same configuration behind. So each one of these is a node into our cluster. In Azure, all virtual machines and virtual machine scale sets will be actually using an instance metadata server that will be attached to all of these virtual machines, and that will be actually managed by Azure by default. So this IMDS, this actually will be attached to all of those virtual machines in order to present some metadata about those virtual machines, so that applications running inside those VMs will get some information like the name of the virtual machine, the name of the virtual network, the name of the resource group, the subscription ID of Azure, and so on. So those could be some useful information for applications running inside those nodes or VMs or inside those virtual machine scale sets for their functioning. So those instance metadata service endpoint actually will be available for all the applications running inside those nodes. That includes the node itself, and that also includes the pods running inside this cluster. So if I have a pod running right here and another pod running right here, so all of these pods will have actually access to that metadata instance. Until here, all is fine actually. There is no issue right here. This instance metadata will be accessible through an endpoint that will be accessible only to these virtual machines. And that endpoint actually is this one, 169.254.169.254. So this means these pods here can connect to that endpoint. So just by using a simple curl command, I can connect there to that address. And then I can query some of the APIs available there to get the same metadata available here. Now AKS clusters actually that creates those virtual machine scale set will be using a managed identity. So we would have here somewhere a managed identity created as part of my cluster. So we would have the kubelet identity, the identity of the control plane, the identity to connect to the ACR, the identity to connect to the CSI driver, and so on. So we would have one or many managed identities into our cluster. Let's call it MSI here. This managed identity will be attached to all of the VMs of my virtual machine scale set, and it will be attached actually if we take a look at the identity section of the virtual machine scale set, and then we look at the user assigned identity or the system assigned, we'll see one or many managed identities available there. So this means those pods will be able, that are already able to access the IMDS, they will be also able to access that managed identity. Why? This is very important because actually this managed identity will expose its information. At the end, this managed identity will expose an access token, okay? It will expose it actually through this IMDS instance. So this one will connect to here in order to expose that access token on one of the endpoints of this right here. So it would have something like identity /OAuth2/token, something like that. So we can use that URL, pods from here can use that URL to get the access token. And now here is the dangerous thing. This managed identity, we said, it will give us access to some Azure resources, okay? So if I'm using the kubelet identity, this will give me access to the Azure resources like the ACR, for example. Azure Container Registry. And if I get an access token to that ACR, this identity would have the role ACR pool. It means I can connect to the ACR, I can get the images from that ACR. I can download the images. Some other more interesting scenarios are the access to the key vault. If we enable the secret store CSI driver within our AKS cluster, this means we will have a new managed identity that will be created. It will be attached to the IMDS, and then any pod in here can access that managed identity. Another use case could be also for the files, for the file shares, for the blobs, for the storage containers, for the database, for Azure Monitor. Remember, those OMS agent actually is using a managed identity in order to communicate with a monitor, and we would have lots of other scenarios. Maybe also it's worth mentioning the application gateway. If we are using Azure Application Gateway Ingress Controller, then that will use a managed identity attached right here, and this managed identity will be used by pods right here. So typically, in a cluster, we would have many managed identities. Each one will be used by its own pod. So for Application Gateway, it will be used by Ajik, for example. For the ACR, it will be that access will be granted through the kubelet managed identity, and so on. But here, the fact that we have one or many managed identities attached to IMDS, attached to all the VMs here, this means that all the pods inside this cluster, even a malicious pod, would have access to this IMDS instance. This is by default, it's not secure by default actually. All the pods here are exposed, all the managed identities are exposed to all the pods in this virtual machine scale set. So we did actually have a solution for this issue that is using AAD pod identity. That is now deprecated, and it will be replaced by workload identity. With pod identity, actually it will intercept all the calls to those managed identities and will allow and will whitelist only some specific pods to access a specific managed identity. We said the dangerous thing is that here all the pods in my cluster would have access to the managed identity. It means if any of my pods gets compromised by by a hacker, and if they get access to one of these pods, they don't need to install a new pod actually. They just need to get access to one of these pods, and here they will be able to access those exposed managed identity through the IMDS endpoint. So what would be a better solution here is now to use the network policy. Network policy, that does not mean to replace the pod identity, but that is actually a solution on the network layer for this issue. So from here we can leverage network policies in Kubernetes. Network policy that could be something like Calico or any other network policy engine. And the network policy, what it will do actually, it will go to deny access to the IMDS. So this means any pod that will try to access the IMDS instance in order to get access to the access token exposed by that managed identity, it will be validated first. So let's say for this pod right here, it will be allowed to access. But for some other pods, for this malicious pod right here, it will be denied the access. How we can achieve that? So through this network policy, we will actually deny all access to the IMDS endpoint. It means that here we'll go to deny that endpoint 169.254.169.254. So it will deny egress to that endpoint. It means no pod can connect to that endpoint. And then it will go to create some exceptions, where we'll go to allow traffic for some certain pods. allow for pod A, for example. If this is going to be the pod A, it will be allowed to access. So this means here we need to pay attention to this security issue in AKS. Actually, it's also present in some other cloud providers like AWS, where they have the same issue where they expose this IMDS, and then that will expose some access tokens to these pods. And that means also we need to keep and to pay more attention to the airbag roles that we give to this managed identity or to the MSI. We should always use the least privileged access in order to reduce the impact of having one of these managed identity exposed by a malicious pod. I hope this was helpful. Thank you.